Hello, so today we will talk about quite interesting stories. Usually it's connected to the self-sovereign identities for sure. Last time we have a chat that verifiable credentials have some challenges for the privacy preserving app. Today we will talk about some other aspects of this problem, but we will focus on the thing that called the self-addressed data. So self-addressed data, it's not a new concept, it's a quite old one, but let's start from the idea of the addressing spaces. Yeah, so if you're familiar with programming, I hope so, you know that memory have the addresses, and actually you could build some data structures and all of the things in memory just with the data and set of pointers that can connect this data somehow together. So same thing as the file system or the hard drive, that we divide the hard drive on some blocks, and we have the some layers that connect blocks to something meaningful, and we could go further and further, that for example the databases have some organization and so on, that actually allow us to address some piece of data. And for example, even if you will take JSON or XML files, we could say that in the scope of this particular file, we could address data via the JSON path or XML path and so on. So we have always the possibility to address some part of data in some addressable space. It's clear. So self-addressing data. It's not the new concept. You will see this concept in IPFS, that you use the data itself to derive the address of the data. So, and it's simple, but for this concept in IPFS, you have the hash, and then you have the distributed table that say where to find this particular hash. So that's already the good start. But what about self-addressing piece? And self-addressing piece and self-reference pieces require us not just to take the hash from the data, but reinvent the new way of storing data and serializing the data. And this is a part of the much bigger topic that I came to talk with you one day. It's the key event logs, and they faced with the need to build the composable event streams. So it's they have even a composable event streaming representation as the special form of the serialization of the data, where you focus not on the format of the data, but on the data itself. So, for example, we have the challenges in verifiable credentials, that they are JSON-LD and JSON, and the JSON is quite robust but quite noisy format, that it's not so useful for the IoT and the binary representation, and it could struggle a lot because, for example, it's a text representation that you could have the new line and code it differently in different operation systems, and it's even this could trigger a lot of problems. And if in a serialization process we will focus on the data itself, so we will ignore the delimiters, we will ignore formatting, the spaces, we just focus on the concept that we have the fields. So the field name and the field value, and these fields are tuples, and tuples are composable, and we take care to serialize and actually transmit the information mainly about the data part. Then it will give us the possibility actually to ignore the formatting and interchangeably combine the text representation like JSON and CBOR representation as binary. And it's not the last piece of this formatting. Another formatting, that you have the cryptographic information as a native citizens there, so it's the binary representation of the signatures that are more compact. But the main idea of the self-addressing data, that you grab the data, ignore the formatting, grab the data, and after that you do the serialization in a way that you have the special placeholder for the cryptographic digest of this data. So you have the data together with the cryptographic digest of the cryptographic signature, and this signature is the unique address of the data itself. And this unique signature is the self-addressable identifier, and the self-addressable identifier together with the data, that special placeholder, will form the self-addressing data. And you could combine the text together with the binary. You have this authenticity of the data because it's the signature. So, and you have the unique way of computing this identifier. So why it's so important and why we talk about this thing? Because it unlocks us a lot of interesting properties. First of all, right now we have self-addressable data that could connect with another self-addressable data, and it's yet another concept called the authenticity chain data containers. And this authenticity chain data containers, I believe that it's a future representation of the verifiable credentials, and it's yet another standard that guys from the Kerry work for. What kind of problems it solves? So you have a VC and you have, for example, the schema, and right now it's the weaknesses of VC because schema is the external link, and somebody could hijack the link, change the schema, change the meaning of the fields in the context, and maybe it will influence how you process the entire VC. Self-addressable data give us possibility to embed the schema as yet another self-addressable data, and then we have the way of verifying the schema was not changed, the schema is valid, it bound the schema together with the data. For example, I have a field that confirm my education, and I could include to the verifiable presentation together with the VC that have this field, maybe the VC from my university, and they will be linked together because you could use the self-addressable identifier and create some kind of addressable space in a knowledge graph. So you are able to build this acyclic data graphs, and it's quite compact and secured way. So I believe that the next versions of the verifiable credentials and verifiable presentations will take some advantages of the self-addressing data in future, because the self-addressing data make it more secured, more addressable, more composable, and you know the JSON-LD itself, it's made for the linked data, and right now we have self-linked data that we could build a data graph that authentic, addressable, we know that it was not changed, and we could compose quite complex structures all together. So that take a look to the site, take a look to share and all other things. I will leave the links in a video. Maybe in my next video we will talk about the Kerry itself. It's quite interesting thing. It's how the industry right now is moving to have the distributed off-chain DIDs, and it's quite important for security. So that's all that I was keen to share with you. Subscribe to our channels and share some news with us, what you're using and what for. So choose